Okay, sketch the graph. Before I like to sketch the graph, I'd just like to see, how big do I need to make it so it's on the screen. X greater than or equal to 0, we know that means to the right of the middle. For this one, the x-intercept will be 3 and the y-intercept will be 2. That's easy. This one, the x-intercept will be 3 and the y-intercept will be -3. So we need to go a little bit below the middle. And this one, x is 20 and y is 4. So our y values can have to go from -3 to 4. Our x values are going to have to go from 0 to 20. Let me make it. -4.5, right. But it'll have to be below the middle. I'll get it right here. Okay, so let's make this 20, because that's and then I'll make halfway through as a 10, halfway through as a 15, halfway through as a 5. Right, this one should go up as high as 4. 1, 2, 3, 4. This one's going to have to go down 1, 2, 3, 4, 5. Okay, so let's do the first one. I'm going to leave that one for the end, the x greater than or equal to 0. Let's do these right here. Do the first one in blue. X is 3, y is 2. That's going to give us from about here to, here to here. And I'm going to draw that as a line, blue. Okay, let's switch. And let me make a little dot here. That's this one right here. So we know which ones we're taking the intersection of when we find the vertices. Then we can switch to red. Right, that'll be this one. That will be x is 3, y is -4.5. X is 3, the same spot. Y is -4.5, there. Draw our line. Change color. That's close enough for government work, as they say. And the last one, go back to that. Let's make it a purple. That'll be this one right here. And that'll have an x-intercept of 20 and a y-intercept of 4. And draw our line. Purple. I'm just going to pretty close, like that. Now we got to get the shading right. So the first one was a greater than or equal to 6, so that means it had to be on that side of the line. The second one was a less than or equal to 9, which means the origin side, 0, 0, less than or equal to 9, that's this. The last one is a less than or equal to, so it's definitely on the origin side. That's there. And we didn't put in that, but that's going to mean that it's to this side. So here's the feasible region. It goes from here, down to here, up to here. So how many vertices do we see? 4, right? And some of them we got. This one we've got. That's a 3, 0. Right, this one is a 0, 2. This one is a 0, 4. Right, there's only one that we have to actually solve for, right, and that would be the intersection of the red line and the purple line, which are these two right here. So how are we going to solve for that? Again, you could use, except I don't want to go there punching on the calculator. I'll just solve this by some other method. How about, since this one's got a 1x, I'm just going to use substitution. I'll say this is x equals 20 minus 5y. And I'll plug that into this. 3 times 20 minus 5y plus 3y, no, minus 2y, wrong place, equals 9. So that is 60 minus 15y minus 2y equals 9. This will come out good. Negative 17y equals negative 51. So y equals 3. And if y equals 3, then we can figure out 5 times 3 is 15. 20 minus 15 is 5. So x equals 5. So this point is 5, 3. Okay, and then what do we do with those 4 points? Plug them in 4 times, right? 4x. So let's see. Z equals 4 times, I'll start here, 3 plus 3 times 0, 12. Z equals, here, 4 times 0 plus 3 times 2, 6. Z equals 4 times 0 plus 3 times 4, 12. And the last one, hopefully this will be more than 12. Z equals 4 times 5 plus 3 times 3. 9 plus 20, 29. Okay, so we're supposed to pick both the min and the max. So here's the min, here's the max. So there will be one problem, which is not a word problem, but just a linear programming problem like this.